Some exercises about Maclaurin and Taylor series. Find Maclaurin series of the following functions. The first function, e power minus x. We know that e power x is given by sigma x power n over n factorial from 0 to infinity. This is correct for any real number. For x, any real number, we have this formula, which could be written as 1 plus x power 2 over 2 factorial plus x power 3 over 3 factorial plus etc. So let's change each x by minus x. So e power minus x will be sigma minus x power n over n factorial from 0 to infinity. So it will be, if I give n 0, it's 1 over 0 factorial is 1 minus x plus x power 3 over 3 factorial minus x power 4 over 4 factorial. Here x power 2, okay. So here 2, then here 3, etc. 2 factorial, 3 over 3 factorial plus etc. So this is the final answer. This is correct for any real number x. The next exercise, find Maclaurin. Maclaurin series means about 0. So let's write this as e power 1 times e power x power 2. Then this is e times sigma x power 2 power n over n factorial from 0 to infinity. So this is e outside sigma x power 2n over n factorial from 0 to infinity. So this is our final answer, and we can write this as e outside times, if I give n 0, so I will have e 1 here. If I give n 1, so it's x power 2, so e x power 2 over 2 factorial plus e x power 4 over. So here 1 factorial. Then 2 factorial plus e x power 6 over 3 factorial plus etc. without stop. And this is correct for any real number x. The next exercise here, remember that sine x is x minus x power 3 over 3 factorial plus x power 5 over 5 factorial minus x power 7 over 7 factorial plus etc. This is correct for any real number x. So let's change each x by x power 2. Sine x power 2 equal x power 2 minus x power 6 over 3 factorial plus x power 10 over 5 factorial minus x power 14 over 7 factorial plus etc. Let's divide by x. Sine x power 2 over x will be. Now I will suppose here x is not 0. So for any real number in R, so now this formula is correct for any real number in R without 0. So here x power 2 divided by x, it's x minus x power 5 over x over 3 factorial plus x power 9 over 5 factorial minus x power 13 over 7 factorial, etc. So this is correct for any real number. Now, new exercise, find Taylor series of the function fx about number a. The first function, e power x, about 1. So let's write the function fx, which is e power x. Let's write x minus 1 plus 1. It's e power x minus 1 times e. Now let's use the formula this e, I will repeat it here, times e power x minus 1, it's sigma x minus 1 power n over n factorial from n equals 0 to infinity. And this is the Taylor series of the function e power x about 1. And this is correct for any real number. The next exercise, ln x. We know that ln 1 plus x is given by x minus x power 2 over 2 plus x power 3 over 3 minus x power 4 over 4 plus etc. How to remember this? We know that 1 over 1 minus x is 1 plus x power 2 plus x power 3 plus. So this is correct if x between minus 1 and 1. Let's change instead of x minus x. So 1 over 1 plus x, it's 1 over 1 minus x. So we can write 1 minus x plus minus x power 2, it's x power 2, the same. Minus x power 3, it's minus here, plus x power 4 minus x power 5 plus etc. And this is also correct when the number between minus 1 and 1. Now let's take the integral. If I take integral of this term, it will be ln 1 plus x will be the integral of 1, it's x, integral of x, it's x power 2 over 2, integral of x power 2, x power 3 over 3. So this is my formula. Minus, plus, then minus, etc. And this is correct for x between minus 1 and 1. So my formula here, always on the interval minus 1, 1. Now I need ln x. How to calculate ln x? So let's write here. Let's write ln. I need x minus 3. So let's write fx equal ln x minus 3 plus 3. Then I know the formula for 1. So let's write ln 3 times 1 plus x minus 3 over 3. So this is ln 3 plus ln 1 plus x minus 3 over 3. Now I can use this formula here, where instead of x, instead of x here, I have this term. So let's continue. So I can write ln 3 in the beginning, plus each term here is repeated, x minus 3 over 3 minus. Instead of this term now, x minus 3 over 3 power 2 divided by 2 plus. Instead of this term, I will have x minus 3 over 3 power 3 divided by 3 divided by 3, yes, then etc. So this is exist if the term x minus 3 over 3 between minus 1 and 1. So x minus 3 between 3 and minus 3. Let's add 3 to all sides. So x between 0 and 6. So this is a Taylor series of the function about 3. Now this is the last exercise. Find the first 3 terms of Taylor series of the function e power x power 2. So I mean here e power x power 2. Even without writing parentheses, I mean that. Okay. Because if it's not, if I mean e power x power 2, it will be e power 2x. Okay, so let's continue. Let's write here x power 2. Okay, so to solve this exercise, let's remember the formula. We have this formula that any function fx, to write the Taylor series of this function about a sigma derivative of order n at the number a over n factorial times x minus a power n from n equals 0 to infinity. This is Taylor series of fx about a, x equal a. Now we have, if we want to write this in details, at 0, if n 0, so 0 factorial is 1, x minus a power 0 is 1. The derivative of order 0 of the function f is the same as the function f, because there is no derivative. Zero derivative means no derivative. So fa plus the first derivative of f at a over 1 factorial times x minus a plus the second derivative at a over 2 factorial x minus a power 2 plus etc. So now this is the first term, term number 1, here, term number 2, here, term number 3. Let's calculate these three terms. So our function is fx is e power x power 2. So the first derivative is 2x e power x power 2. So the second derivative will be, if I take e power x power 2 outside, the derivative of the first is 2 times the second e power x2 plus the first 2x times the derivative of the second. Derivative of the second, it's 2x e power x2 times 2x 4x power 2. So 4x power 2 e power x2. Now let's go back to our number 1. I have here 1. So let's calculate what is f1. f1 is e. What is f derivative at 1? It's 2 times e. What if 2 derivatives at 1? It's e times 6e. So let's go back, write the final answer here in red. So my function e power x power 2 will be written as the function at 1, it's e here, it's e plus the derivative 2e times x minus 1 plus the second derivative 6e divided by 2 factorial times x minus 1 power 2 plus. So these are the first three terms.